Hello, welcome back to CS61C Spring 2019 Midterm 1, Question 2. And for this problem, it's mainly about memory addresses and address locations as well as where they belong in the memory layout. So I think mainly for this type of problem, there's two ways to do it. You either look at the problem questions and try to search up if I look up, maybe I'll find out where it is. But also another way to do it is just to go through all of the code and then find out where you can you basically do the entire code and then go back to the problems. Either way I think is valid, but I think the second way gives less prone to errors because you automatically do all of it first. While the first one you might look at something, look up, and then do the next question and then forget what you did the first time. I think also another strategy is just to look at the ones that you need. So we have 0, map0.key, map1.value, and add entry. And I think after you add the entry, you probably populate map0, map1, and then add entries up top. So it looks like we have to do all of it anyways. So let's just get straight into it. If we look at the top, size is 0, and because this isn't declared in the stack, it's declared inside of a function, it's not going to go into the stack. It's going to go into static or global. So we get size, and then this place is equal to 0, which for now I don't really worry about. I'll just put it for now. But yeah, it's in the it's static or global and it's not stack because it's not inside of a function. Then we declare a struct, and I'm not entirely sure where it goes in the memory location, but I don't think we need to worry about that. And then also add entry I'm not sure where add entry is somewhere, but I'll ask about it later, and I'll explain why. And then lastly we have main. So let's just start doing main. First we declare map, and map here is declared inside of a function, right? And even though a lot of people might say, hey, but it's malloc, you are correct in which some of it belongs in the heap. But map itself is a pointer. Oh, I'm going to label this 1, 2, 3, 4, 5. This map itself is a pointer to somewhere in the heap. So it's like what map points to is something in the heap, but map itself is a pointer that belongs on the stack, right? Because it's declared in a function. So in this function main, it has map, which points to the map entries, map 0, maybe it's key and value, and then map 1, and then it's key and value. But for now, there's more, but I'm not going to worry about those for now. But mainly map, the key thing to note here is map is declared in a function call, so it belongs on the stack, but it points to somewhere malloc, which means that it points to somewhere in the heap. So that's number 1. Number 2, we start with key. Again, it's a car star, so it's a pointer, right? So it's a pointer to somewhere in the heap, and this place is the key, right? So key, I don't really worry about, but basically it points to somewhere in the key. And then lastly, we also have value, which, this is the key details. I'm not entirely sure. And then lastly, we have value. Value is going to belong on the stack, right? Because it's declared on the stack, but it points to also somewhere on the stack as well. And I think it's just the next 20 bytes for key. Oh no, oops. For value. And basically, you need 20 extra bytes for the actual stuff to hold what value, to hold the 20 cars in value. And value itself is really just a pointer to that. So, it just points downward. And then now we call add entry. So whenever we call a function, we open a new frame, look at CS61A, woo. And with this, we start doing add entry with map K and V. Now notice here, K and V are going to be static variables. If you guys remember, static, what is it? String literals are ones that are declared with just quotations instead of having a car array, and these belong in static. So that means that we're passing in K and V, which are things in static and global, into the add entry. So what's first going to happen is we're going to create a 0. Right, so 0, and I think it belongs in 0, 0, 0, but actually I'm not entirely sure, so let's not do that. But 0 points to somewhere in null. I'm not even going to worry about that, but the main thing is that it points to null. But it belongs in the stack because, again, we're declaring it inside of a function call. Now, the other thing we have is we're going to set map m, which is map 0, size is equal to 0 first, and we set the key and the value to k and v. So we're going to basically set this key and point it to this k and this value to point it to this value. That's all that's going to happen with these next two lines of code. And then we increment size by 1, so I'm just going to add 1 here. But this is very important because map 0 dot key would belong in the heap, but if we try to go to where the key points to, we're going to actually end up in static. And you'll see that it's important later. And then next we do another function call, and we do add entry. Actually, we don't even have to do that one because, again, this is like the part where I was like, okay, well, some of the doesn't need it, but actually I'm going to do it anyways. So we do the key and value, but this time we're passing the two things inside the stack into it. And then we're going to go into int 0 equals null, so we're going to open another frame, and we're going to point to null again. Oops. And then we're going to have to set the key. So size has been incremented already, right? So by last time's add entry. So now we're going to set the second one, map 1's key and value to be key and value. And I think this key and value would be pointing to, right? Because I think they're pointers to, they contain the memory location for, they contain the memory location, like the memory address of where the pointers go to. So if key has the value of somewhere in the heap, now this key also has a value that points to the heap. So this would, I think, just point to here, while the value would point to somewhere in the stack for, I think, number 3. Yeah, number 3, which is here. Yeah. I think it's either that or this. I think it might be the second one, so. Because I think when you dereference the value, you should be able to get the 20 bytes, not another pointer. So yeah. So this is the one I'm pointing to for the 5th one. And then we increment size by 1 more. And again, I don't really worry about that, so ignore that. So I think this is done. We can start working on the problem. So if we look, it asks, this is very important for the question. Make sure you read the question correctly. It says that where in the memory layout each variable is stored. Where, right? Where asks for like what address or what location it starts in. So not where it points to or not where it dereferences to. It's where it exists currently. It's basically asking for what the address is. So 0 itself is either one. I think they messed up here. They're like which one, but it doesn't really matter. So I think that's why they probably didn't clarify it. That 0 itself belongs in the stack. It points to null, yes, but I don't really know why you care about that because it literally just asks for where does 0 belong, and 0 belongs in the stack. So we're gonna select stack here. Now map0.key. I think I'm gonna link in the description something about like a Google Doc about another link that a Google Doc that has a link to the order of operations. But for now, just assume that the brackets and the period have precedence before the star, and the bracket and the period have the same precedence. So we do left to right. So we get map, we dereference it by going to the first object, or first struct, and then we dereference it again, not dereference, sorry, that might be wrong. We get map, we look at the first object, and then we get the key. So this key currently, right here, points to somewhere in the heap. But if we dereference it, because if you notice the star, we're pointing to somewhere in the static, right? We're pointing to the k, the string literal k. So this is actually going to be static. Now map1.value is going to be a little bit different. Map 1 is going to be in the heap, right? And then we do dot value. That gives us the value in the heap. Now, some people might be like, oh, cool. That means it must be in the stack, right? Because value points to the 3 up top, right here. But that's wrong. Because of the fact that we never dereferenced. Map1.value has a pointer to somewhere, like has the pointer to value. But the thing is, they're only asking for where does map1.value live? Where can you find that? And you actually find that in the heap, right? Because that's where map1.value lives. It might point to somewhere, but again, we only care about where the address is. Now, lastly, add entry, which I forgot to which I just didn't mention before. So I think functions, like the name, like the declaration of a function, just belongs in code. I think the function, like these functions, are actually just in code. I don't really know like a good explanation. I think that was just something I had on my cheat sheet. But functions are on code because I don't think you really declare them in a stack. And then I don't know why they're not static, but they're definitely not heap as well. So it's between static and code, and I think it makes sense because it's part of the actual code. So I think add entries in code. Now, the second part of the problem asks for bubble the comparators that would make the following expression value to true. And then this one asks for like the actual variable. So I think it's referring to the actual value. Yeah, so like what like the value has. So I guess you'll see, but map and 0, right? So map itself, map points to somewhere inside of the heap. So map has the value of something in the heap, right? It has this value right here. And with this value, we can consider 0. 0 has the value of something in null. And I think that 0 has the value of 0x000000. I'm not entirely sure why, but I think that when you point to null, you basically point to nothing. And I think 000 is like a invalid address. So then we just assume that's null. And anything, like any value in the any memory address, you can't have a negative memory address, right? So you're going to be greater than 0 because I just said 0 is invalid. So this is greater than, right? Because map is in heap, and 0 is literally the number 0. I think it's actually like 0. And then key and address of size, right? So key, as we see, has the value. I think key has the value of something in the heap as well, right? So key lives on the stack, right? The address of key is on the stack, but it contains a pointer, right? So it is a pointer, so it has the value of something in the heap, which would be this thing right here. And then with this, that means that the key is on the heap, but the address of size belongs in static, right? There's literally no other size, right? We declared size, it's in static / global. The address of that is going to be somewhere in static, and heap is always greater than static, right? Because heap is above static. So we have no problems there, and that means this one is also greater than. Now let's look at map and key. This one's a little bit tricky, and it requires some reading of the question that I forgot to mention. But let's look at this. So map, right, is a pointer to somewhere in the heap, so it has the value of something in the heap, an address of the heap. Now key, on the other hand, or on the same hand, or also is a pointer to something in, right? It's right here, pointer to something in the heap. Now if we read the question, whenever you see something like this, it's like, oh shoot, something's wrong. And it's either undefined or not enough information. But if you read the question, you'll see, assume malloc memory grows upward, allocating the first available address. So that must mean, if you notice my drawing, I did this on purpose, right? I created map 0 and map 1 and all the maps below key details, because I know that map was declared first, so this many bytes for map was all underneath key details. So map points to the start of the heap, while key details points to a little bit afterwards. So that means key details has a higher location, higher address than map, which means that key is actually going to be greater than. So even though they're heap and heap, technically the right side wins because declared afterwards. And then heap grows upward. Cool. And then lastly, let's look on to value and address of 0. So value is, as you can see, declared on the stack as the third thing, and then it points to, is still on the stack, right? Because we never malloc anything for value. Value points to the stack, and it points, I think usually it's like no matter what, it's above the frame that we created right here for add entry. No matter what, this value, it might not be exactly 20 bytes underneath value, but it's 20 bytes for value someplace below value, where value is created, right here, and greater than this new frame. So if you look at this, value and 0 are both on the stack. But value was declared first, and we already know stack always goes downward, and it opened a new frame for like add entry for 0. So either way, whichever 0 you do, this value's memory address location, like memory address, like what value it points to, is right here, right? Has to be greater than 0. So this one is also greater than, or not also, it's the value is greater than. Now we're almost done. Last problem. I remember skipping this problem because I thought it was super hard because I didn't get any of these beforehand. I guessed on all of those. But if you look, it says how many bytes of memory are leaked by this program. And I was like, oh. I came back to it and I still didn't get the bubbling questions, but I think I was able to get this one. The reason why is because the question asks for how many bytes of memory are leaked. And if you guys remember project, leak memory means that you forgot to free something, right? Whenever you malloc something, or calloc or realloc, and you never free it, you're leaking that memory. So I was like, okay, cool, let's look at this problem. If you look at this, there's literally no freeze, like at all. Which means everything that you malloced is going to be leaked. Now, how do we figure out that? Well, we know that the size of a struct is how many things you have in your struct, right? So a car star and a car star. The main thing here to note is car star is not 1. Car star is a pointer, which means it has 4 bytes. Which means it has a total of 8. So the size of, and 8 is, I think, tightly packed already, so you don't even have to worry about all that. I don't know if they might have this, but for our year, we got lucky. There was no like worry about how to like tightly pack something or if whether or not you had to. It was perfect. So the size of the struct is 8, and we had 10 of those, right? So that's 80 bytes here. Oh wow, 80 bytes here. Now, on the other hand, we have a malloc size of car times 10. This one is just 1. Because the size of a car, I think, in our class, for any like class, unless they specify differently, most likely the size of a car is 1. So then you can multiply this by 10, and just get 10 bytes. Now, if you add these together, 80 plus 10, you get exactly 90 bytes. And that concludes problem 1, 2, and then problem 3 is going to be risk 5, so look out for that.